Welcome to another C++ video in UG Academy. In the last two videos, I talked about how we can define pointer type in C++ and how we can treat a pointer as an array. So in this video, I'm going to talk about how can we release the memory being pointed by the pointer back to the system. During our everyday computer usage, we can often delete a file within the file system. Have you ever wondered whether we can delete a variable within a C++ program? The answer is yes and no. For static variable, we cannot. For example, x is a static variable, and we cannot delete it. Once we define it, it's stuck in the program until the program finishes its execution. However, this is not the case if it is a dynamic variable. In other words, a variable being pointed by a pointer. So we have three cases here. The first case is a simple pointer pointing to a double variable. Okay, so it's the most simple case. And the second case is a little bit more complicated. It's still a double pointer, but in this case, it's actually pointing to an array of double. And then we are going to use a for loop to initialize the elements within this double array. And then for the third case is the most complicated. The data type we define here is a pointer to pointer. And then it's pointing to an array of pointer. And then for every pointer within this array of pointer, we are going to create another array which actually contains the data we are going to store. And then I intentionally make this size bigger because I want to look at a significant difference in memory usage after we have released all the pointers here. You may also notice that in this video, I'm not using Visual Studio Code. Instead, I'm using Visual Studio. The main difference between Visual Studio Code and Visual Studio is that Visual Studio is a fully featured IDE, so it has a diagnostic tool after compilation. So during the program execute, we can have a look at its memory consumption. So we can verify that our delete methods work. We have indeed freed the memory being pointed by our pointers. Now let's have a look at how to free the memory being pointed by the pointers. In the first case, it's very simple. We simply apply the delete operator to the pointer variable. And then we assign the null pointer value to the pointer variable. Do note that when we apply the delete operator on the pointer, we are not deleting the pointer itself. We are only deleting the memory address being pointed by that pointer. In other words, release it back to the system. So it's no longer within our program's graph. So after this operation, the address of stored in this pointer is no longer valid. So we assign null pointer to it, which means that this pointer is not pointing to anything. Although this step is not absolutely necessary, but it's often a good practice to indicate that a pointer is not pointing to anything, instead of storing an invalid address in it. For the case of having a pointer pointing to an array, it's also very similar. But instead of using the delete operator, we use the delete operator followed by a bracket here. We do not have to specify the size of this array, since the compiler can automatically infer how many memory we have allocated. So we only have to use a bracket without specifying its size. So similarly, after the delete operation, we let this pointer point to a null pointer. So in the third case, which is also the most complicated 2D array case, we are going to need to use a for loop. So this pointer is actually a pointer to a pointer array, and for every pointer within the pointer array, it actually points to a data array, which stores the actual data we want to store. So for every pointer within this pointer array, we are going to use the delete bracket operator to release the memory being pointed by that pointer. So using for loop is the only choice here because we do not have operators such as delete bracket. Okay, so for a 2D array, the only valid choice is to use a for loop. So after deleting the array pointed by the pointers within this pointer array, we are going to delete the pointer array itself, which is another delete bracket operator applied on this pointer to the array. Again, we can also assign null pointer to it. That's a good practice. In some program, you may also see people using something like this, equals to null. It's basically the same thing. Null means null pointer. Okay. It's basically the same thing. Usually, for every new operator, we need a delete operator to release the memory address allocated by the new operator. So they come in pairs, new and delete. But it's not absolutely necessary to delete, because after the program ends, all the memory will automatically be released. So only use it when necessary. Okay, new and delete, they come in pairs. Let's have a look at the result. The getCharacter function here simply means that we are going to wait for a user input. It's from the IOStream standard library. Great. So we have the diagnostic tool here. It shows that our program is currently using 200 megabytes of memory. And then this is because we have this large array here, 5,000 by 5,000 array. Now we are going to press, and the program will continue executing from here and releasing all the memory we have previously allocated. As you can see, the memory usage dropped sharply. It dropped from 200 megabytes to almost 0. This is because we have released all the memory we have allocated here back to the system. And that's all for today.